Hello everybody, this is Mr. Strunkslane here. I wanted to make this quick video for two reasons. One of them being is a good review of division for long division for fourth graders if they're starting to struggle a little bit and they might want some refreshers on long division. And the second reason is actually because I've had parents really have a few questions about division, why we're doing it a certain way, and where some of these numbers are coming from. So I'm going to talk a little number theory in here too, to kind of explain why we do division the way we do today. And so hopefully this video is just there as either a refresher for students or for parents, just so they kind of understand if they're looking at their students' work as they're doing some practice of whatever, on what's going on. So this is a topic that all three fourth grade teachers have worked on, is long division. And so hopefully this will be a little review for the fourth grade students and a little just introductory course for parents. So when we talk about division, usually we start talking about area. We talk about area before division, and this will make sense as I go through. But if I have a box like this, and I know that some of this box, this side is 3 and this side is 4, that means that there's 3 lines this way, there's 4 lines this way, and the area of this box would be 12. My area is 12, and I know that because I can count them. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if I have a really big box, it's not very efficient to count these. So instead, what we would simply do is we would know that 3 times 4 equals 12, which is my length times width equals my area. And if we know that, we're doing well and we have a good understanding of area. So let's keep that idea that we understand that area is equivalent to length times width. And let's transfer that over to if I have a box. And if I know that this area of the box is 20, and I know one of the sides is 5, what is the other side? What is the length of the box? It would have to be what number? 5 times what would give me 20, and you'd have to know that it's 4. And so now that we know this is equal to 4, let's transfer this idea to a much bigger one. This is pretty simple. Most fourth graders know this coming in. Let's take the same idea and expand this into how this fits in with long division. So if I take a very big box and I know the area of this very big box is 64, and I also know that it's 4 high, I need to figure out what the length is, or the width actually. I need to figure out how wide this box is, but I know the area is 64, so knowing that length times width equals 64, I know that 4 times something, which is my W in this case, is going to equal 64. So what is my W? Now I need to use division to work myself backwards. Now, what I could do is I don't know how long this whole thing is. I know my area is eventually going to be 64. There's 64 little boxes in here. And I know that the area is 64. And it's also 4 high. What I could do is if I drew a line here and cut this box somewhere. And let's say that I knew that this yellow section was now 10 wide. Great. If this is 4 high and 10 wide, the area of this box must actually be 40. All right, I'm doing well. I still don't know the area of this box, but if I know the area of this box is 40, I want to know what the area of this is. Well, simple math would tell me that whatever's in this box is going to be 40 less than 64. So if I go 64 minus 40. I can subtract these. And I know the area of this box has to be 24. Great. So the area of my pink box is 24. Well, if it's 4 high, how wide is it to have an area of 24? What number times 4 gives me 24? And hopefully most of us are going to get that the width of the pink box is actually 6, which is great. So if the yellow box is 10 wide and the pink box is 6 wide, how wide is the green box? Simple math again would tell us all we're going to do is combine these two numbers, and 10 plus 6 gives us 16. And now I know that 4 times 16 gives me 64. I'm doing pretty well. It's making sense, and some of us get this. Now, this is really a tough way to do this area model. We teach multiplication this way, so there's an easier way to do it, and I'll show you. But I just want to touch on the area model again. The idea is here that we're taking a big number, like 64, and we're breaking this down. That is the idea here. Big number, 64, breaking it down into smaller boxes so that we can solve. That's what we want to do. Another way to think about this is, again, if I have 64 things, we can do this in a partial quotient method. So if I have 64 and I want to divide it by 4, this looks probably very familiar to a lot of parents. This is the way we typically do this. We set it up with one additional, and we do this. I call this a hangman's gallows because it kind of looks like if you play hangman. It's kind of the hangman gallows there. And we're going to use this. So now again, I want to take this big number, 64. It's a big number, hard to work with. We're going to break it down into smaller pieces. If I have 64 things, and I want to divide them between 4 people, how could I do this? One way is I could give, if I think about this as I have 64 things to give to 4 people, right? And we actually model this in class. I take out 64 cubes, and how am I going to divide these among 4 people? Is I could give every person 10 of them. Every person could get 10. And if I have 4 people and I gave every person 10 of them, that means that I handed out 40 things. If I subtract that from each other, now that I started with 64, I gave everybody 40, how many do I have left? It makes for a nice simple subtraction problem, and I end up with 24. Great. Now, if I have 24 things left, I still want to give them 24 things left. This is called my target number. Right here is target number. I want to give them to 4 people. How can I divide 24 to 4 people? Hopefully our 4th graders are pretty good with their numbers, and they can tell you that 4 times 6 would give you 24. And if I had 24 things, and I give out 24 things, that means I have 0 left. And since I started off by giving out 10 and then 6 more, that means I handed out a total of 16 things to each person. And so my answer would be 16. And I can tell that 64 divided by 4 would be 16. And these are the same numbers that I just used in the prior slide. A little bit different. This is a lot easier to understand. Again, I'm taking 64. I have 64 things. I give out 10. And then I give out 6 more. And I end up giving out all of them. Pretty easy to understand. Where this is kind of nice is there's more than one way to do this. For some kids, maybe they're not really strong with their math facts. And so they could back up. And we'll back up. And maybe they don't know that that 24, or what number times 4 would give them 24. So maybe they knew, all right, well, I know that 5 would get me close, which 4 times 5 would give me 20. and I could subtract this and I would get 4 left. All right. Not done yet. I still have 4. I can do this. I'll make this a little smaller so I have room. And now I could do one more set of 4, take 4 more away, end up with 0. And now again, I'll add all of these up. 10 plus 5 plus 1 would give me 16, which is my answer. There's lots of ways we could do this if we don't know our simple facts, or if we have large numbers that we're not comfortable with. There's different ways we can do it. So again, here I would have known that it's 24, and I know that 4 times 4 gives me 16, so I could have done it this way, and I still would have gotten the correct answer of 16. So this one's nice because there's more than one right way to do it. And it works out really well that way. Because there is more than one way, if we have big numbers, it's easier to break them down. The whole idea is, again, taking a big number that's hard to manage and breaking it into smaller components so that we can get it. So let's try this. Let's do one together. You can pause the video. I'll give you guys a problem. You guys solve it, see how you do. So let's do a nice problem like, let's say 83 divided by 5. Let's take some time, try to work this one out. You can pause the video. I'll give you a second. Solve it, see how you do. There's more than one way to get to the right answer, different routes to get to the same point. So let's give it a try. But right now I'll solve it. So what number, my first question, what number using 5s, 5 times what gets me close to 83 without going over? Just like the Price is Right. My target number is 83. I want to get close to it without going over. And so what would work, usually a lot of times we start with a 10, just because 10s are easy. Okay, 5 times 10 would give me 50. Great. Now I can subtract that. Nice, easy subtraction problem. 33. Great. Next question. So my target is 33. Close as I can without going over. 5 times what gets me close to 33? Hopefully a lot of people look at that and go 6. 5 times 6 gives me 30. And if I subtract that, I end up with 3 left over. There is no number that I can do to take that away, so I end up calling this the remainder right here. I can't go any further because I can't, even if I put a 1 here, I can't go 5 minus 3. It doesn't work, so I can't go any further. That is my remainder. So again, my answer happens to be 16 again. And I have a remainder now of 3. I could also write that as a remainder of 3/5. But I've got a remainder of 3. And that's the important thing. Hopefully that's what you got. You could have gotten the same answer by doing it a different way. And you could have went back, and if you're at this point, maybe you don't know your multiplication tables that well, you could have went 5 times 4 would have gotten you 20. You could have subtracted that, and you would have gotten 13. So you would have needed to do 2 more, which would have got you 10. 3 left. Still same answer. You would have gotten 16, remainder 3. So it's kind of nice that way. It works out. You can do it different ways and still get the same answers. And this works. It's scalable. So if you have really big numbers where you're dividing a 3-digit number by a 2-digit number, you can still work this out. And it's really nice that way. So if I had a really big number, such as 253, and I want to divide it by 12, I can do that. So that's a 3. I can do this. And it works out really well because if I don't know my 12s very well, I can just do 10s. All right, multiply that times 10, that'd be 120. Okay. 133. Cool, I could do another set of 10. And I would get 13. And now I know I can only do one more. And I would have one left over, which means my answer is 10, 10, 10 plus 10 plus 1, which gives me 21 with a remainder of 1. So it's scalable. You can do this. Many parents watching are probably thinking of the standard algorithm. And this is the way I learned it when I was a kid. And it's probably the way most parents learned it. And so this is the simple method of knowing the order of divide, multiply, subtract, bring it down. And so if I go back to 64 divided by 4, oops, I don't need the hangman scale anymore. 4, I learned this as, all right, we're going to go 6, how many times, or sorry, 4, how many times does that go into 6? There's one right answer. There's no way to do this. There's only one correct way to do this. It would go in there, of course, 1 times. That's my division step. Now I'm going to multiply, and I'm going to go 1 times 4, which is, of course, 4. And now I subtract, and I learned that I subtract next. Why do I subtract next? I don't know. That's why I was just told, so I do it. And I keep doing this. I bring it down. How many times does 4 go into 24? And I hopefully know the math facts well enough. That gives me 6. And 6 times 4 would give me 24. And I'm just trying to follow. Now I subtract because that's the next step. And I get 0. There's nothing left to bring down. So my answer is 16. This is the way I learned it. There's nothing wrong with it. The problem being is this is certainly, or ultimately, it's only for computation. You get this answer. Why do you get this answer? Because you followed the steps. It really doesn't break the numbers down, I don't think, in the same way. And it all goes back to a certain thing called number theory. And that's the most important thing in all of this as we talk about number theory. Is we want to take big numbers, break them down so that they're manageable. And what is nice is as kids get better and better at our partial quotient system, they'll actually be able to do this in their head. So again, the really big part about this is that we're learning number theory. Being able to take really large numbers, break them down into smaller things so that they're more manageable. That is the idea. When I was in 4th grade, I learned long division as well. I learned it the standard algorithm way. You divide, multiply, subtract, bring it down. Why do you divide first? That's just what you do. Why do you multiply? It's the next step. They just tell you that. And I just never really explained it. We just had to learn it because my teacher told us that we wouldn't always have a calculator. And we need to learn that. Well, I don't know about you guys, but I've got this kind of stuff sitting around all the time. So as far as just understanding how to computate a equation, it isn't necessarily that useful of a skill anymore because there's always other ways to do it. What's more important is being able to understand the numbers behind it, the theory. Being able to take a really large number, break that number down into smaller pieces so that they're more manageable. And that's something that's scalable. It's used in really big ideas. And if you start talking about into any sort of design, software design kind of thing, you need to be able to scale that and be able to take those big ideas, break them down. And so that's where it is. It's also much more practical, being able to take a really large number because, again, if you get pretty good at that partial quotient thing, you can do a lot of it in your head. It also gets you a lot better at estimating and understanding those numbers, being more comfortable and being more fluent with those large numbers, which is more important than being able to just straight up solve it using paper pencil. So that's kind of where those ideas come from. It relates back to that number theory idea. And so if students are working and doing they're working on their math journal, it looks just like this. You have that at home. If kids are working backwards in that, that's great. Or filling in those things that they haven't done yet. Or even if they are working ahead, there is a lot of division review. And I just wanted to go through and kind of give you an idea of where those numbers come from. So hopefully this helps a little bit and get as a quick crash course or a reminder on how partial quotient division works, and that's the one that we're really using. I know I showed you area model, but that's just kind of to build into the partial quotient. So the partial quotient method is really what we use a lot in fourth grade, and so hopefully this gives you a little bit more of an idea. And if you guys like this, if it makes more sense, please let me know. You can add a comment on the dojo page. If it's still really confusing, let me know. I'd be happy to go over another video, maybe a little more in depth on just the partial quotient. And if you have any questions about like the whole number theory and how philosophically this works into educational pedagogy, I'd be happy to have that conversation, but it's probably a little long for this. So feel free to touch base with me if you have questions on those. But thanks for watching, and I hope you guys have a wonderful day. Talk to you later.